Hey, what's up? In today's video, we'll be looking at how to install OpenShift Origin version 3.10 cluster on top of DigitalOcean infrastructure. So we'll be spinning up three nodes on DigitalOcean. One will be the master node, the other two will be the app nodes, and we'll be using a couple of tools for this purpose. We'll be using a tool called Terraform, and then we'll be using the official OpenShift Ansible playbooks to provision OpenShift cluster on top of existing infrastructure. This process consists of two steps. One is you create the infrastructure needed for provisioning the OpenShift cluster on top of DigitalOcean. For that, we use Terraform. The other tool is the other phase is using Ansible to create the OpenShift cluster on top of this newly created DigitalOcean VMs. So you have to download this particular repository over here, badri/OpenShift-Terraform, and make sure you download tag v1.0 because this is the version which I've tried and tested to be working with this version of OpenShift and DigitalOcean. There are a lot of other experiments going on in different branches. So let's download that first. Make sure you have Terraform installed on your local. And Ansible will install eventually when we clone the OpenShift Ansible repo. So I unzip OpenShift. You can see that it consists of a module directory, and then there is a README here. Let's open and see what's there in the README. So you have to give a couple of inputs. One is you have to create a DigitalOcean read-write API token, so that Terraform consumes this token and then creates the infrastructure on your behalf. So let's go ahead and create a DigitalOcean token. You should have a DigitalOcean account, and spinning this cluster and running this will cost around $90 to $100 a month. So I'm just going to create it and destroy it. It's a good way to get your feet wet with OpenShift if you really wanted to try it out. I don't really recommend a mini shift because at the end of the day, it's just a local setup. So if you want a real feel of how a production OpenShift cluster looks like, you have to do something like this. You have to provision it on real cloud infrastructure. I've generated this token. I'll export it as an environment variable. There are a lot of other inputs which Terraform consumes from you to create the infrastructure. Like you can have a say on the number of app nodes you're going to spin up, the memory or the size of the VMs which you're going to spin up for both the master and the app nodes, and what base domain you're going to use for this whole cluster, and what kind of images are you going to use. I prefer to use the CentOS image here. Let me walk through the section called variables.tf. .tf is actually the official extension for Terraform manifests. Terraform is a declarative tool for provisioning your infrastructure across any cloud. Think of it as the equivalent of AWS CloudFormation. So the only thing Terraform does is provision infrastructure for you. If you want to provision or configure software on top of that infrastructure, then you use a tool like Ansible or Chef. But Terraform just takes care of the infrastructure provisioning part for you. Technically, Ansible does the same thing as well, but then Terraform is more declarative in nature, in the sense that you specify the desired state of your system, and Terraform brings your system to that particular state. Whereas Ansible is more procedural. You say do step 1 followed by step 2 and so on. And the other major difference is Ansible does not store the state of your infrastructure, but Terraform does it. So whenever you run Terraform, Terraform takes into context the existing state of your infrastructure, and then alters it according to your desired state. In Ansible, you can kind of achieve that in a very rudimentary fashion, but then you're better off using a specialized tool like Terraform for that purpose. So here I specify the public private key pair, which is exclusive to this OpenShift cluster. So you can generate it using the SSH keygen command, and you give the path here, and I specify the region where I want to run my cluster, and then this is the master VM size, and then the node size, the number of nodes I'm going to spin up. And OpenShift needs some kind of apparatus for persistent storage. There are a lot of ways to go about it. If you're using some provider like AWS, then you can use elastic block storage for the persistence part. In DigitalOcean, I tried my hands on working with DigitalOcean volumes and dynamically provisioning them, but then it's not quite ready for prime time yet. So what I do is I create a lot of volume bricks, as they call it, and then attach it to all the nodes I provision in the system. And using these volume bricks, I create a GlusterFS setup, and it acts as a single storage entity for the whole OpenShift cluster. I'll demonstrate how that works in a moment. And then this is the base domain for the OpenShift cluster. It's example.com, but you can change it without Terraform wanting to prompt you about that. So this is what you do. I have a specialized domain for just this demo. It's a subdomain, so I'll be using that. Make sure that it points to your DigitalOcean name servers before you create the domain, and then point it to your VMs. My base domain is dev.lakshminp.cloud, which I use for just this demo. And after that, I run a command called Terraform init. Now, Terraform consists of 3 stages. One is the init, second one is the apply, and third one is the plan. It's the other way around. Init and then plan followed by apply. Init is actually going to download all the external modules which you're using in your Terraform manifests. And plan is going to sort of do a dry run on what infrastructure will be creating, and then compares it with the existing state of the system. And apply actually executes that plan into action. So let's run Terraform init first, and then see what output it gives. So it checks for DigitalOcean provider, and then the template and local. These are all standard Terraform providers. A provider is a Terraform entity which provides you with some functionality. Like a DigitalOcean provider provides you with DigitalOcean cloud manipulation capabilities, and then template is going to help you generate a template based on a few input variables and then a template. We'll come to why we use template in this workflow pretty soon. And then we use something called a local to open and write a local file. So let's take a look at the main file. So this is what we are using. I'll dig into it real quick. Before that, let's run Terraform plan. So it says that there are 14 resources to add. Mostly the resources are the VMs themselves, and then the domain name management, and then the volumes. So let's run Terraform apply. It's not necessary to run plan because it's just an optional step. It shows you what it will be creating when you run Terraform apply. It prompts for a user input. I say yes, and then it provisions it. It takes a few minutes to provision the whole infrastructure. You can see that it's already started creating the VMs. So I declare a module called OpenShift DigitalOcean, which it takes from this relative directory, and then I supply it with inputs. And let's quickly jump into the module and then see what it does. This module does 2 things. 1, it creates the infrastructure needed for our OpenShift cluster, and then 2, it generates an inventory which is consumed by Ansible in the next part of this whole workflow. So an inventory is an Ansible input which Ansible takes and then runs or provisions software based on whatever inventory input we give. And this inventory is generated by Terraform, because Terraform knows the IP address and the domain names and all the other stuff about the nodes which it just now created, and it gives that as the inventory input to Ansible. There are many ways to go about it, but I choose this as the most simplest way, and I'll tell you why in a short moment. So we see that these resources are created and they are up and running. You can see that it created an inventory file, inventory.cfg, and then a pre-install inventory.cfg. Now let's quickly open inventory.cfg. So this is the input for our next stage, where I run Ansible and then provision an OpenShift cluster. And I'll walk through this real quick. Before that, I'll show you the pre-inventory file as well. We install some prerequisites in all these nodes, like Docker and then the network settings and all that stuff. So I've written a custom playbook for the same, and this is the inventory for that custom playbook. So let's run that first. You can see the custom playbook is inside the path pre-install / playbook. So this playbook installs all the prerequisites needed for the OpenShift cluster. This will take a few minutes. So in the meanwhile, let's really run through the OpenShift DigitalOcean module. All the variables and all the manifests are there in .tf files, and there is really no order here, because Terraform internally creates a graph based on the dependencies of each and every entity, and then it runs through that and then creates infrastructure for you. This is the module level variables file, and it contains almost the same stuff we saw in the top level variables file. You can override them if you want. It consists of things which are rather hard to override, like the image you use for the OpenShift cluster. I use a CentOS 7, and then the name of the master node, which is OpenShift-master, which is what we have here, and then we spin up the clusters in BLR, Bangalore region, and we have a VMs file which will create a DigitalOcean key pair with whatever key pair file I gave, and then create the master droplet and then the node droplets based on whatever parameters we gave, and then it will create the domain mapping for these nodes, and it will create the volumes as well and map the volumes to the nodes. This is for GlusterFS, like I mentioned before, and finally it generates the inventory file using the inventory.tf. This is very similar to templating languages like Jinja or Handlebars, if you have used those. So what it does is it takes in an input template file like inventory.template.cfg, and then these variables it substitutes with the actual values which I give as inputs here. This code is really not very neat and it's very hacky, because I personally don't like the fact that Terraform doesn't provide a lot of higher level constructs like conditionals and then looping and all that. So I have to work around those limitations and then generate these templates. So there's no like, if value is this, then generate this chunk of the template, else generate that different chunk, and so on and so forth. So that part is really limiting about Terraform, but there are a lot of hacks or workarounds around that. If you want, you can check out the issue queue, where I have mentioned a lot of other enhancements and then things which are yet to come. It's a sort of a roadmap, and it's very discrete single line thing which I understand. I just use this to keep track of the development here for myself. Feel free to raise any issue you face here, or you can also help me with any of these issues which you consider you can give a hand with. So we have the repository prerequisites which are getting installed. Now the reason why I chose a 3-node setup for this is GlusterFS at minimum requires a 3-node setup in order to work, or else I would have gone with a single all-in-one node. I'll show you the configuration file for Ansible. These are all inventory groups like masters and etcd. It's very similar to a .ini file, but it's not the same as that. And you have nodes in the system, and you label these nodes into one of these 3 or 4 categories. You have a master node, and an infrastructure node, and then a compute node. Infrastructure is used to house all the OpenShift related infrastructure like the Docker registry, the router, and all that stuff. The compute node is used to host all the apps and services which you create in your OpenShift cluster. All-in-one is something which can host your apps, your infrastructure, as well as your master related pods. So I can configure a single all-in-one node and run it as a master and an app and an infrastructure node as well, and then give it a slightly higher memory. But the thing is, I'm not able to pull off or get GlusterFS working on a single node. So that's the reason why I have a 3-node setup. If you are setting up OpenShift on a different cloud like AWS, then you can get away with a single all-in-one node which acts as a master as well. But in a true production setup, you have high availability setup where there are like 2 masters which are load balanced by a load balancer entity, and then you have multiple app nodes and then a dedicated set of infrastructure nodes. But that is not the case here. This is a sort of a semi-production setup, I would say. It's not as bad as something like Minishift, but it's not like super robust either. Something you can get away with or deploy your small applications or staging environments or something like that. By the way, one more thing to consider is even if your OpenShift master nodes go down, your apps are not going to go down. It's just that you can't operate or scale your apps or do things with them. They'll still keep running. So that's one thing which you should be aware of. So now that we have installed and provisioned all the prerequisites, there is a prerequisite check which you have to run. Before that, you'll have to clone the official OpenShift Ansible playbooks. Let's do that. You have to make sure that you clone the 3.10 branch. If you don't do that, then you're going to get very bad or unexpected results. Once you do that, there is a requirements.txt here, and this is very, very important, probably the most important thing in the whole workflow. You have to use the Ansible version which is recommended by this repo. I had a different Ansible in my system, and then I could never successfully provision the OpenShift cluster because of an Ansible version mismatch. That's the last thing you need. I spent a lot of hours debugging this. So let's install the Ansible which is dictated by this repo. Before that, you have to create a virtual env. Let's do that. I create a virtual env here so that it doesn't mess up with my existing Ansible or Python libraries, but feel free to skip this if you don't want the virtual env. Because I use the fish shell, I activate my virtual env in a very weird way. If you use bash or some other shell, it might be different. So I do a pip install requirements.txt. Well, that is running. We'll see what the next steps are. The prerequisite check is going to ensure that your infrastructure has all the prerequisite software and the hardware for running a stable setup of OpenShift Origin 3.10. But you can cut corners in some ways by mentioning it in your inventory script. Like the official recommendation for running a master node is 16 GB of memory for the VM, but then we are running on a 4 GB node, so it's not written on stone that you have to run a 16 GB VM. So you can actually skip those checks by using this variable OpenShift disable check. So I skip the disk availability, the Docker storage, the memory availability, and lastly the Docker image availability checks, so that my prerequisite run doesn't fail. So that is one thing which you can alter here in this variable. Let's run the prerequisite playbook. I have to make sure that I give the private key here because otherwise it's not going to access my VMs. Same with the deploy cluster command. Before that, let's make sure that we are running indeed the version of Ansible which was prescribed here. So I run which. So this is the one in the virtual env, so we are good here. I run the prerequisite check using the .inventory.cfg, which got generated with the Terraform run. Oops, I guess I messed up the parameters. I have to give inventory over here. Now that takes some time to run the prerequisites. While that is running, we'll quickly go through. The GlusterFS node group is where I specify what all devices will GlusterFS be consuming, and then the actual device file path. This is very specific to OpenShift DigitalOcean setup. And these are Ansible variables which are consumed when installing the cluster. And then I install a containerized version of all my OpenShift components. They are not processes, they are containers. And this variable is actually obsolete. I still have it hanging around in the new version as well. I have to remove this. And then the deployment type is Origin. There are a lot of flavors of OpenShift. You have the OpenShift container platform, the dedicated, the Origin. The Origin is the community upstream version. You can also install the commercial edition also with this playbook. So you have to specify the type here. Now we are installing OKD, which is Origin. So I specify the type as Origin. And then this is the release version. You have to make sure that this is 3.10 as well, because you've cloned a 3.10 branch of the Ansible playbook. And you can configure a ton of other options. I'll just show you the rest of the configuration options which are there in OpenShift Ansible. This is an example configuration inventory. So it's pretty well documented, each and every parameter in this, but the thing is, it's like staggeringly big. It's like 1,000 lines of configuration. There are so many pieces of configuration, and rightly so, because the domain is very complex and you have a lot of dials to control in OpenShift. So one of the reasons why I generate the inventory from Terraform is to avoid reading or going through this this file and then writing your own configuration file, which is mind-boggling and time-consuming. With this, you can get off to a quick start and then set up your own cluster. Let's wait for the prerequisite step to finish. The actual deployment script is pretty long. It's going to take around 30 or so minutes. So it's a good time to take a break when you run the install script. We've not come to that yet. There are some post install steps as well which you'll have to do to ensure that all the components are working. We'll do that once the installation is finished. And lastly, I want to mention that in Terraform it's a module, so I follow a modular structure for this. It means that you can extend or reuse this module to suit your own setup. I made it as modular as possible, so if you want to increase the number of nodes here or the size of the volume or things like that, you can feel free to fork this module and then do it. That said, you can also add more functionality to it. Like for example, I don't have this whole setup running on an open a DigitalOcean private network, but I added it pretty recently, but it's not there in this tag. So there are a lot of scopes for enhancing this module as well. Yeah, so the script is run, and it looks like we are good to install OpenShift. So let's run the final command to provision OpenShift. I did it wrongly. Finally, we have the cluster set up and installed. It took around 45 minutes, and let's go ahead and do the post install steps. We can log into the nodes using the SSH command. You have to give the keys which we specified when we were supposed to install the cluster, and we see that the pods are running, their registry and then the console and the router and all that. They are running fine. And the next step is you create a user for OpenShift to log in using the hdpassword command. This is not how you create a user typically. You specify it in the Ansible playbook itself, but this is more for pedagogical purposes. So we have created a new user called admin, and there is this entity called the storage class, which is common for both Kubernetes and OpenShift. It acts as a liaison between the end users of the cluster and the underlying infrastructure, where it contains the infrastructure details like what Kubernetes cluster are you running, what is the Hekiti endpoint and all that stuff. So the end user is not supposed to know so much detail. They just need to provision a new volume. So storage class is the entity which acts as a mediator between the volume requirements for the cluster users and the infrastructure. We already create a GlusterFS based storage class. We just make it the default storage class in this step using this command, oc patch. Now that this is done, let's go ahead and log into our newly minted OpenShift cluster. Because we don't use a proper HTTPS certificate, it's going to give you this error, but it's okay to ignore that. we give the credentials which we created in the ht password command previously. And once we log in, we'll be able to see a lot of pre-created application templates for us, which come by default with the OpenShift Origin installation. These are the templates. Let's go ahead and create a new app for verifying our whole installation. We want to make this a non-ephemeral app, meaning it'll consume the OpenShift storage which we just now created. So let's create a Django plus Postgres app. The console shows us all the entities which get created when you deploy or push a new app. You can see that it creates a Postgres service and then a Django service as well, and then binds both these services together. It does a build first where it pulls the official image for Python, and then pulls the demo source code for the Django example from here, and then builds an intermediate image and pushes it to the OpenShift Docker registry. So you can see the running logs over here. This is the pod status. It's usually in blue. And you can see that Postgres has created a storage and provisioned it here. It's bound to a new volume claim which got created on your GlusterFS setup. This is the URL which gets created when you create an app. The format is generally the app name followed by the project name. Project is the equivalent of a namespace in an OpenShift cluster. And then there is a wildcard subdomain apps.dev.lakshminp.cloud, which is configurable on your Terraform manifest. So it creates a route using all these input parameters, and the build is successful. And we have the app up and running right now. It's in blue color. You can scale this number of pods up or down. So let's go ahead and hit the newly created app. So this is the scaffold which got created from the official OpenShift Django example. You can see that it stores the page views in Postgres, and every time we refresh this value changes. So we have successfully deployed OpenShift and created a new app on top of that with persistent storage and storage class and all that, using the Terraform manifest which I showed you just now. So one more command which we are yet to see is the Terraform Destroy, which destroys your OpenShift cluster. So once you run that, it's going to remove all these entities which got created before you provision the cluster and then run Terraform apply. So let's run that as well. Terraform Destroy is going to remove all the nodes and the volumes and the domain mappings as well. So I give it a yes, and it removes everything what got created right now. So in a future video, we'll be looking at how to deploy applications in different styles and workflows on top of an already installed OpenShift cluster. This was just a demonstration of how to install and set up OpenShift. There are a lot of other aspects which you have to take care of, like namespaces, teams, and hooking up your workflow with your source control and all that. We'll see that in later videos. So all the nodes which got provisioned, they got destroyed. That's it. Thanks for watching. We'll meet with a new video. Bye bye.